Hello, in this video, I will show you how to set up real-time monitoring of your decentralized applications using Sentio. On this dashboard, we monitor TVL, daily active wallets, the aggregated matrix of transfer, mint, and burn events. You can also submit individual event logs into the system, then you can zoom into one log for further investigations. What's better is that we can correlate logs with matrix. Say if I saw a spike here, I can zoom into this range and click the matrix and go direct to relevant logs. This will give me a much smaller scope to investigate. Okay, let's get started. The project we're going to use today is cbETH. This is basically Coinbase staking service. User deposit ETH and get cbETH in return. Let's write a project, monitor the status of cbETH. First, go to Sentio docs and set up the dependencies. We only require you to install Node.js, and we require version 16+, so make sure you install that version. Then you can go to app.sentio.xyz to register the account. It should be pretty straightforward. You can just follow steps there. And then you can copy this command to log in. That will actually redirect you to the browser, and you can log in here. Then go back to CLI. You are logging in successfully. Then we can use Sentio CLI to create a project. Go to this quick start page, copy this command, and run that on your command line. Replace the project name by Coinbase. That should create a project for you. Then you can open it by any IDE you want. In my case, I use IntelliJ, so open its project here. On this file structure, you can see we have APIs and the source code. Source code is where you need to write your actual logic here. And API is the standard EVM API here. First, install the dependencies so this thing can actually compile. You can also just manually run yarn install. That will just install everything. Okay, it's pretty fast, and it should be okay now. See, everything compiles now. What we need is actually put the relevant APIs into this directory so we can start the program cbETH. How do we do that? We need to first find the actual address of cbETH. That's already on the Coinbase website. You can go here, and that will take you to the Etherscan link, and go to this tab, and you'll find this is actually a proxy. So for proxy contract, you actually need the API of the underlying contract. So click here, click verify. That basically gives you the actual contract address. And Sentio has a command line to actually automatically fetch the contract. So I already have it here. So to run this command, that will actually automatically create this API here. So we should rename this just for the convenience. Rename this file, and then we can run yarn Sentio gen to generate all the relevant types, so we can reference from the source code. We need to delete everything here so we can start writing code for cbETH. We know cbETH is a standard ERC20 token, so it has a standard transfer, mint, and burn events. We need to monitor those, and we also need a price feed because we need to know the price of ETH at any given timestamp. In addition, we also want to know the total supply and the exchange rate. Those are the variables in your contract, so we need to get that from the view functions. First, we can start by defining a file that contains all the constant we might need to use. So let's define this. So here we have two contract addresses we want to use. So I'm just going to copy it. One is the CPX proxy and the actual implementation. Then we will start importing the relevant libraries. First is all the CPX generated types. So all these are generated from the these APIs. And then we'll copy over some utilities from Sentio SDK. This is how we get the price, and these are some token utilities. Counters, gauge are the primitive types of observability, so you can know more details from this page. So on this page, it has all the definitions here. So basically, counter is like every time you add a delta into this value, either subtract or add. And gauge is like an instant value at a timestamp. Using both, you can monitor a lot of things. And next, let's import the constant we have here. Right now, we only need the proxy. So we're gonna start monitor this contract. We know we have a transfer, mint, and burn events, so we'll be monitoring those. And we also want to trigger a monitor every certain number of blocks, so we can, read a contract variable by view functions and then write that into a gauge. So basically, we can do this. This, and we know we want monitor transfer events. We know we want monitor mint events. We know we want to monitor burn events, right? And we also know we want to monitor the build functions, contract variables at a certain interval. So we have this on block interval triggers. Okay, then we need to start writing the actual handlers. Let's start with a simple one. Let's start with the mint handler. So let's do go mint event handler function event transfer events and context stake context. Okay, so fix the spelling here, and then what we need to do is first get the token info. So this is done by a utility function, which is just calling an ETH call directly. Okay, we get this token info, and we can actually normalize the amount by this. So this is also token info decimal. Okay, then we get the actual amount. So then we need to record this into our into the system, and then we have then we need to define all the variables. So here's the option here. this is basically a metric option, so you can just use this. This is basically pre-aggregate, so the metrics are aggregating every 60 minutes. This is to optimize the speed of the front-end loading. And let's define that particular metric here. Like we need this mint, and we also need the accumulative counter here. So we are both monitoring the it at the gauge and also as a counter. Okay, so then we do this basically using gauge to record that amount at that timestamp, and using the counter to add amount to the accumulative sum. So notice we don't need any timestamp here because it's already inside the context. Okay, so we can do pretty much the same thing for burn as well. So I'll just copy it here, and we need to define those burn stuff. So you have a mint burn here. Okay, so yeah, putting this inside here will make this compile. Right. So why this is not compile? Oh, this is the wrong type. Okay, then this compiles now. Now we move to event transfer. So this is a little bit different. So transfer event function, transfer event context, stake token context, and the first few lines are very similar, so we just copy it here. So one thing to notice is here it's actually value. So yeah, we need to fix this as well. So you can see here, so this is actually amount, and for the transfer it's actually value. So make sure you get this field name right. And we need a specific counter and gauge for both. So let's define this transfer gauge register transfer, and okay, so use this here. So we are monitoring the basic stuff for transfer as well. And transfer is a little bit different. We want to get more information, but because this is the activity that the user involved the most. So we also want to compute the daily active wallets based on this. So to do that, we need a third data structure, which is event logs. So you can see the definition here. So you can write the individual logs into the system, and you can later perform either event analytics on it, or you can also just do full text search on it. So let's go here and start emitting event logs. So it's actually pretty simple. So you just do event logger and emit, and here you emit basically a name of the log. Here I call it just transfer. So, and then I emit a struct of that information here. So one thing to notice is you need to write this in distinct ID. So here I just want to use the .2. So this basically is used to compute the daily active users based on this distinct ID. So if you are not computing the uniqueness metrics, and you don't need this. And then we add all the random fields. I'm just gonna copy, just save them time. So all these are just custom fields here. Okay, and then we're done with transfer events. So we can put it in here. So we're all set with the first 3 events. Now let's move to block handler. In this handler, we want to monitor the contract variables like total supply and exchange rate. We want to trigger the monitoring every X blocks. So that's when we need to use block handler. So let's start writing this handler. So this part will be very simple. So you just first get the token info here and use the standard isCall to get the contract variables. And you want to scale down and normalize this. So as you can see, Sentio generates all of the types for you, so it's pretty convenient to write those out. So the others are very repetitive, so I just copy it here. So you'll basically compute the total supply, exchange rate, and put them into a gauge. Okay, and then we also want to monitor the TVL, total value locked. In that case, we need to know the actual price. We only know exchange rate here, but we don't know the actual price. So we need a price feed API. Sentio provides this API for you, so you can get the token's price by its address. So here we use this API to compute the price for WETH. So you can just use the WETH price here, and this times the exchange rate will actually give you the price of the CBETH. So this, if you go into this, so this you basically give the chain ID and calling type, which is address, and give a timestamp that will actually return you a number or undefined if there is error. So we also need to check if the return is undefined. So we can do this if not WETH price, and we log a warning, the price found, and return. And then let's compute the CBETH price. So if exchange rate is not 0, we need to wrap this with big decimal because this is a big decimal, and then we can compute the price here. So big decimal WETH price and divided by exchange rate. The else we just record the 0 because we cannot divide 0. Okay, and after that we can just use a gauge to record those things. So we can simply record the CBETH price, and also we can record the TVL by simply times the price with total supply. Okay. Yeah, and then we put the block handler here. That will actually trigger this on the certain block intervals. Okay, so we finished most of the codings. We can verify all the details if we have any mistakes. If not, we can start uploading this to Sentio. So check this file, sentio.yaml. This has the project name here. So you can just go terminal and run yarn sentio upload. This will actually upload this into a project under your username. So you can see here this is not found, so it will actually create a project for you. It's under my username and the project name Coinbase, and then type yes, and then the upload is successful. We can go back here, see we have this project here, go to data source page, you can see it started queuing here. So it'll take some time for this to be uploaded, so let's wait a while. Okay, now the backfill is done, so you can see the status processing, and it's actually tracking the latest status. So you can see the history here, so it was actually backfilling stuff, and you can also see the progress of processing the latest blocks. Go to metrics page, you can see those are the metrics we are tracking. So those are basically things we defined in our processor.ts file. And now let's start building some dashboard. Let's see, I want to build a dashboard that tracks the TVL, right? I can go here and I can do TVL, and I can select metric of TVL, and that basically gave me the TVL here. So I can just create this and have a TVL here. Another example would be to track the DAU. So I see one DAUs here, and I can go here and select this events I'm tracking, and using this to use the native functions daily active users, and that will give you the DAU of this contract. Okay, I will omit the full process of building all the dashboards. So it's basically a no-code process. You don't need to write any code. You can just combine all the metrics and build this dashboard out. I will have a further video to explain the details on this topic. But today I'm going to just directly import the dashboard because I already built it in the past. So you can directly import this, and this should give you the full view of the full dashboard. Okay, this is same as what I showed in the beginning of the video. So we have everything here. Let's move to the logs page. We submit logs using the event logger, so you can actually zoom into every logs in details. In addition, we allow you to filter based on the attributes. For example, I'm interested in finding out the large amount of transactions. Let's say I want to find any transaction that's larger than 5,000. So then you actually filter out logs. You see 50 logs found. Only 50 transactions in the last 3 months are actually larger than 5,000. If you change its range, you can see the results are different. So you can easily filter in the logs based on time range. So looking at the log itself, I found this address seems to have a lot of large transactions. You see here 0x, 2f, happen again here and here and here. So what if I want to find all the transactions involving this address? I can do this by full text search. So click here and copy this address and just do a full text search here. And you can see we highlight every transaction, either this address at the from or at the to. So click this, you'll know all the details here. So you basically list all the large transactions involving one address here. Now let's move to alerts. Let's say I want alert through some channel when some certain events happened. I can do that first by creating a channel. So we support alerting through email, Slack, webhook, and Telegram. In this example, I'm gonna use email. So give a random name here and put your email address here. Now you have this channel created. Then let's move to alerts page. Click add alerts, and you can see we can choose either metrics-based alert or logs-based alerts. In this example, I'll be using logs-based alerts. So first, you need to type in this query matching a certain condition. So we basically use this transfer event we submitted. And you can do is doing a count star, or basically counting the number of transfers in the last 5 minutes. So if it's greater than a threshold they give, maybe 5, and then you start to fire the alerts. Here we choose the channel we created just before, and we can say this large transfer here, and we can attach a custom message body here, and we let it to re-notify this. Alright, then we click save. We have this alert created. Okay, now I have the large transfer alert coming in. Clicking this email, and I saw all the relevant contacts here, all the actual transfers, and that also gives me a link, takes me to the alert page. So this page will show all the instances where the alert fired and recovered, and this will give me the whole history, so I can debug further from this page. Okay, this summarizes the end-to-end example of how to use Sentio to set up real-time smart contract monitoring, and I'll see you next time.